Okay, following from the last video, just very quickly a few exam questions that I found lying around, most of which are polymers, but I saw a few other interesting ones. So this first one, which reaction does not take place in the dark? So that is the reaction of a halogen with a hydrocarbon. So that requires UV light in order to happen. So remember that. All right, this one here, which row describes the type of reaction that ethane and ethene undergo? Well, ethane is a saturated hydrocarbon, so you can't add anything to it. So it's not going to be that or that. And then ethene is an unsaturated hydrocarbon, so you can add to it. So the answer is going to be D. Now, this one up here, esters are made by reacting an alcohol with a carboxylic acid. Which acid and alcohol react together to form the following ester? So if you look, you just break this bond here. I've got 1, 2, 3. So it's going to be CH3, CH2, COOH is going to be propanoic acid. All right, and then the alcohol is going to be HOCH3, which is methanol. That one there. Which structure represents a polymer? Hopefully, this question is very, very obviously C. So that's going to be a protein. Next, there are two types of polymerization. Addition and condensation. Explain the difference between these two types of polymerization. So as we just saw in the last video, addition only starts with one reactant, or the reactants must be unsaturated hydrocarbons. Condensation, each reactant has to have two functional groups, or the reaction involves the loss of water, anything like that. Some plastics formed by polymerization are non-biodegradable. Describe two pollution problems that are caused by non-biodegradable plastics. So there is the issue of disposal of the waste, accumulation in the oceans, and if they are burned, they form toxic gases, anything along those lines. The polymer known as PVA is used in paints and adhesives. Its structural formula is shown below. Deduce the structural formula of its monomer. Super easy. Okay, so you can see, look, I've got CH2, CH, and then I've got this thing here, CH2, CH, this thing here. So it's literally just going to be that with a double bond in it. Alright, so it's going to be C, H, H, double bond, C, H, and then whatever this is here. There it is. Okay. Slightly more difficult, a condensation polymer can be made from the following monomers. Deduce the structural formula of this polymer. So like I said, just go ahead, if you're not sure, just draw it all out. So I can leave that bit there for now, although if you want to, you can draw that out as well. And then draw the acid group out so you know what's going on. Okay, and then over here, we're going to have, let's not do that, N, H, H, and then CH2, 6, and HH. All right, and then we're going to lose the water. Okay, so we're going to have CO, CH2, 4, CO, and the carbon bonds directly to the nitrogen. CH2, 6, and H, and then that will bond to the next one along, CO, C2, sorry, CH2, 4, whatever, like that. Okay. All right. Ethanol can be produced by fermentation or by catalytic conversion of steam to ethene, which row shows an advantage and disadvantage for each process. So this is just, you have to know. Okay, so fermentation, it's good because you've got a renewable raw material for the glucose, but you get impure ethanol. You've got to distill it. Catalytic addition of steam to ethene is fast, but we're using hydrocarbons here, so that's going to be a non-renewable raw material. This again, so look, we've got CH3Cl, CH3Cl, HF, HF. So that there is your monomer, which is this one here, B. Okay. Nothing interesting there. Polyesters are polymers made from dicarboxylic acids. Name the other type of organic compound used in the form of polyesters. Well, if it's an ester, you need an acid and an alcohol, but because it's a polyester, you need a dicarboxylic acid and a diol, or a dialcohol. And the type of polymerization is going to be condensation rather than addition. Amino acids undergo polymerization to form proteins. Part of a protein molecule with the linkages shown, missing is shown. Draw the linkages. Okay, so if I've got the amine group at this end is going to be my carboxylic acid end, but then it bonds to the amine group of that one. And then if this is the amine end, this is the acid end, and then that bonds to the amine end of this one. And if this is the amine end, I should get an acid here, and I've got the acid there. Wonderful. Okay. And that is